Today in this demo we'll see how to use auto scaling and load balancers together. So in this diagram you can see the traffic is coming from internet and that is coming to the load balancer, and that traffic is being distributed to 4 EC2 instances right now. Now as the traffic goes high, then the load on those EC2 instances increases. As a result of this, auto scaling kicks in and 2 new EC2 instances are launched. So now this load balancer has to distribute the traffic among 6 EC2 instances. So how to achieve that? We'll see that in the demo. So let's go to our EC2 console first. So as you can see right now we do not have any instance running. It is showing 0 instances. So the first step would be to go to the auto scaling group in the left panel, and we will create an auto scaling group. Let's name this auto scaling group as demo ASG. Then we have to specify a launch template. Now what is a launch template? Launch template specifies the configuration of the EC2 instances that will be launched as a part of this auto scaling group. So we do not have a launch template right now, so we'll create a launch template. Let's give this launch template a name. Let's call it demo launch template, demo LT. We can give it a description. Then let's leave a few things default. Then in AMI, let's use Amazon Linux AMI. Then for the instance type, let's choose T2 micro because we are doing this demo in a free tier. Then let's select a key pair. So we are going to create a new key pair. Let's call that key pair as demo London key pair. That is just in case we want to log into our EC2 instances. Then in the network settings, we can leave subnet default, and then in the firewall, let's create a new security group. Let's call it demo SG. Now the security group, in the security group, we'll allow 2 rules. We'll create 2 rules. First rule will allow SSH traffic coming on port 22, and let's allow it for from anywhere. And second rule will allow HTTP traffic coming on port 80, again from anywhere we can choose as a part of this demo. Then we'll leave other things as default. Then we will go down and see advanced details. In this advanced details, let's add some user data. So I'm writing a script here. So what this script is doing, it is installing HTTPD web server on my EC2 instance. It's starting it, and then it is creating a web page, index.html, and in that web page I have written web page from the host name of the instance. So when the EC2 instance spins up, so we'll see a website with this particular text. So we'll just go and create a launch template. So my launch template is getting created. It's successful. Then we can view the launch template, or we can close it now, and let's use this launch template in our auto scaling group. Now if you refresh it, we'll be seeing the launch template which we just created. We'll leave other things in default, and then we can go and click next. Now we have to specify in which availability zones my auto scaled instances can spin up. So I'll choose all the availability zones. Then I'll press next. I'll leave everything as default. Then I have to select load balancing. So let's attach a new load balancer, because you can also attach existing load balancer, but for me I do not have a load balancer, so I'm creating a new load balancer. So let's create an application load balancer and let's name it demo ALB. Let's make our load balancer internet facing so that traffic from the internet is coming to our load balancers. And then we have to create a target group. So let's name a target group as demo TG. So in this demo TG, all the targets, all our EC2 instances will get registered and the traffic will be redirected to them. Health checks I'm leaving default. Then the next step is configure group size and scaling policies. Here I am selecting desired capacity as 1, minimum capacity as 1, and let's choose maximum capacity as 2. So when scaling up happens, at max 2 instances will be there. Then in the scaling policy, I'm choosing a target tracking scaling policy. Let's leave other things as default. This target tracking scaling policy will be based on the average CPU utilization. And let's give the target value or the threshold as 35 or 30, so that for our demo it's easy to simulate the load. Then instance need, so we can specify by default it's 300 seconds. So this is the cooldown period. So I'll make a separate video describing about the cooldown period and a warm-up time. So this is the cooldown period, and this is the time between two scaling activities. Okay, so let's make it 100 seconds. Then we leave other things as default and we click on next. Then in this step we can add a SNS topic just to send a notification to the subscribed email that autoscaling has been triggered, or instance has been launched, or instance has been terminated, or it has failed to launch, or it has failed to terminate. So we can select event types and notifications will be sent accordingly to the registered email ID. So I can create a topic here using this, and I can now I can specify an email which will be notified when any activity happens. So after this step, I'll be getting a confirmation email on my email ID. I have to go and confirm it, and then my email ID will be registered as a subscriber to this topic. Okay, so then we'll click on next. Let's add a tag. Let's leave it. Tags are optional, so we can leave it. We can review the settings and we can just go and create auto scaling groups. So now let it create. So right now you can see auto scaling group has been created. Along with the auto scaling group, you see one scaling policy, one topic, one subscription got created, one notification, load balancer, target group, one listener. All these things got created. Now you can see capacity is getting updated. So desired capacity is 1, minimum is 1, and maximum is 2. So right now I have 0 instances, but you will see in couple of seconds that one instance will come up since we have specified desired capacity as 1. Yeah, so you can see this instance is in a pending state. So let's check this instance on the EC2 dashboard. So I can see one EC2 instance is in the running state now, and status check is initializing. Let the status check continue, and then let's copy this public IP. We'll copy this public IP address on our browser to check whether our website is working or not. And also let's check the load balancers. Let's check the load balancer that got created. So you can see the configuration that I was doing on the AutoScaling group. So this has also created a load balancer called demo ALB. So I can see now my load balancer is also active. So now I can use the load balancer DNS name to check whether my website is working or not. So I paste this DNS name on the browser, and you will see that my website is working. That means my load balancer is right now distributing the traffic on this EC2 instance which is running right now. So right now I have only one EC2 instance, so my load balancer is sending the traffic to that EC2 instance only. Now let's log into this EC2 instance and try to create some load. So why we are creating load? We are creating load to test that AutoScaling is getting triggered or not. So as the load increases, AutoScaling will kick in and a new instance will come up automatically. So this is a command which you can fire on your instance. This will create some processes which will increase the CPU utilization of your instance. So you can copy and paste this multiple times. So this will increase the load on your instance. Yeah, and you can see now another instance has come up. A new instance has come up, and that is in a healthy state. Now let's go back to the EC2 dashboard and check the status of this instance. So this instance is also in the running state and status check is initializing. Let it complete, and then what we'll do, we'll just refresh our page. Now my load balancer will distribute the traffic on both of these instances. You can see my load balancer is distributing traffic to 2241. This 2241 was my second EC2 instance which got created as a part of when my AutoScaling got triggered, and 124 was my initial instance. So now you can see load balancer is equally distributing the traffic between these two instances.